You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey, everybody. Welcome to the show. Good to see you guys.
Good to be back.
Love it.
Well, I have a fun little topic for you this week.
Okay.
I'm going to start off
excited.
by talking about honeybees, although my topic is not honeybees.
I'm excited.
If you know anything about honeybees, if you know anything about them, you probably know that almost all the bees you find in a colony are female worker bees.
Right. Yeah.
Right?
Mm-hmm.
These are the ones that are going out to collect the nectar and the pollen. They're the ones that defend the hive and will sting you if they think you're a threat. Of course, honeybees famously die after stinging because their barbed stinger will remain in your skin. And when the bee flies away, they're go at guts. Yeah.
Gross.
Technically, it's in order to leave the venom sac attached to the stinger so that it can pump the maximum amount of venom into your body. Lovely.
Right.
Anyway, if you know this about honeybees, you probably also know that wasps have an unbarbed stinger and do not die when they sting. They get to sting you over and over again. Yay.
I've experienced this personally.
Oh, no.
I'm sorry.
I can tell stories about how many times I've been stung.
Have you been stung repeatedly by the same wasp?
One time I opened my mailbox and a yellow jacket got me on my wrist at least twice. So yes.
No. Ouch.
Oh, the wrist. Oh.
Ouch.
That's not great.
I'm sorry.
It's what it is. I love bees now.
Good.
It's growth.
Well, what not as many people know is that only female wasps or bees even have stingers. The stinger is is actually a modified ovipositor, which is an egg-laying structure, so therefore only females have them. And they use it to inject this venom, which is what makes bee and wasp stings so painful and lingering. Or, if you're allergic, potentially deadly.
Right.
Males, of course, do not have an ovipositor, so no male wasps or bees can have a stinger or venom.
Right.
Which, makes them a little vulnerable. But as you probably also know, the stereotypical black and yellow stripes of a wasp or bee are warning coloration, meant to advertise that they're not to be messed with. So also think of like bright or eye-catching coloration of, nasty tasting monarch butterflies or stinky skunks or deadly poison dart frogs.
Right.
And so it was long thought that male wasps were completely harmless and relied on kind of piggybacking off this warning coloration based on the dangerousness of the females for their defense. However, a recent discovery shows that males of some wasp species are not quite so defenseless as they seem. They are fighting back. They're fighting back against predation with their genitals. Yes.
Fantastic.
They are using their man bits.
Why?
Well, hold on. Why are women like this with their ovipositor full of poison, Rachel?
Very, very fair.
Exactly. So they actually do use their male parts to protect themselves against frogs and other creatures that might like to make a snack of them. Some researchers in Japan recently discovered that male potter wasps, this particular species is Antirhynchium gibberfrons.
Beautiful.
Gibberfrons? I don't know. Yeah. Have sharp spines on their genitals that they will use to stab predators that try to attack them. This remarkable ability was discovered by accident by a researcher named Misaki Tsuji of Kobe University. She was studying the life cycle of potter wasps and one day picked up a male wasp, thinking it was safe, and was shocked when she got stung, apparently. Of course, this was not a real sting. It's more like being jabbed with a thorn. But examining the male closer, she saw that she had been poked by these two sharp spines that stick out on either side of the male wasp's genitals. So basically, like, the penis is in the middle and it's a little shorter, and then there are two long, sharp spines on either side.
Yikes.
Yeah. So Tsuji and the paper's lead author, whose name is Shinji Sugiura, devised an experiment to show that the spines were in fact used in defense and not during mating. They first observed successful and unsuccessful mating attempts and found that the males did not use the spines on the females. And then they placed male and female wasps into tanks with species of frogs known to eat wasps. And they would place one wasp at a time in with a particular frog. Some of the males had their genitalia removed, and some had intact genitalia.
Oh,
yeah.
Boy.
Yeah.
Don't love this.
Yeah.
You know, sometimes you have to be, when you're doing this type of experiment, and this is the way that has been decided on how you're going to do it, you have to, when this is happening and you are removing wasp genitalia, you have to be going, what the hell am I doing?
What am I doing with my life?
Like, what?
How did I get here?
Sort of like putting stilts on ants.
Exactly.
Yeah, exactly.
Okay,
so go on.
Yes.
Mm-hmm.
So interestingly, this type of tree frog that they were using attacked all of the male wasps, but ultimately, so attacked meaning like tried to eat, attacked with mouth.
Sure.
Ultimately rejected or spat out 35% of the intact males due to their defensive stinging behavior.
Okay.
Poking, whatever you want to call it.
Because they stung the frog.
All these poor castrated males got eaten. All of them.
Oh.
You know, all these poor castrated males got eaten was not a phrase I had on my bingo card for 2025.
Wow.
So it doesn't
Victoria,
help me here.
We're so early into 2025. I mean, attacked with his mouth also was not on my bingo card.
Oh, God. All
But
right,
it's
go
a
on.
good one.
Yeah. By contrast, 53% of the time, the frogs ignored the female wasps. And when they did attack, they ultimately rejected 87.5% of the females. Presumably because they were being stung, right?
Mm-hmm.
And there was also a size factor. So like the relative size of the frog and the wasp influenced how often the frog would attack. Like if it was a big wasp and a small frog, it wasn't as likely to try to eat it. But interestingly, although this experiment was only on this particular species of wasp, there are many species of wasp where the males have similar genital spines. So it's actually very likely that this behavior occurs in other species of wasp as well, and that it's pretty common.
Wow.
Yeah. I don't have a whole...
I have a friend, a friend of the show, Mr. Brett W. Sieberer, who we've had on a few times.
Yes.
So we're going to have on again soon, actually. He particularly likes to go out and find male wasps.
Bald-faced hornets,
like,
doesn't he?
I think more yellow jacket, like more like a paper wasp. Paper
wasp.
And will find the males and pick them up and like show them to people and have put it in his hand and stuff. And it just freaks people out because they're like, "You're holding a wasp. What are you doing?" You know, and it looks like it's there trying to like sting him, but of course there's no stinger there, and so. Makes you wonder, does a paper wasp are they one of the ones that has that? But he's never been stung, so.
I would also imagine that the sharpness of the spines may vary from species to species.
Sure, yeah. Absolutely.
I feel like You can be bit by a wasp, can't you? They have mandibles.
They have mouths, yeah.
Yeah. I've certainly been bitten by other types of insects, dragonflies notably.
Dragonflies.
Yeah.
I got bit by a katydid once.
Oh yeah. Yeah.
Oh yeah, they'll take it. They'll chew away.
That was a good chunk, and then it pooped on me. It was very rude.
To be clear to our listeners, these animals are not going to come up and try to bite you. Like a dragonfly's not going to come up and try to take a chunk out of you. If you have to grab them and hold on to them, and they're trying to get away. So
yeah,
if you don't
this
grab the insect,
defensive.
Yeah. I know a lot of people are kind of afraid of dragonflies because they seem threatening somehow to some people, and I just want to make that clear.
No, this is like if you are handling them for education or research purposes.
Yeah.
Yeah.
And you put your hand
come out of the sky
and
attack you.
Near their mouth,
One final thing here on my topic, which is that the researchers did remove the entire genitalia of the experimental males, which, as one of the commentators in an article that I read noted, would be fairly traumatic for those unfortunate males.
Yeah, I'm going to go with a yes on that one.
And, might have affected the 100% rate of them being eaten.
Yep.
So he suggested that a revision of the experiment could remove only the spines and leave the penis intact, which, fair. That would be worth trying.
Probably still not great.
Still not great. I don't know.
Wow.
I mean,
that is that's a lot to take in.
Yep. We're gonna
has a real stinger on the tail.
All right, good night, folks.
Gotta say my sources, which this article is entitled Male Wasp Genitalia as an Anti-Predator Defense, published in Current Biology, December 19th, 2022. I also got some good information from the UK's Natural History Museum website and from Scientific American. All right.
It's funny, it's not the journal I thought you were going to say that was published in.
Not this time, alas.
Inside joke for our regular listeners. Okay.
All right, we are going to take a break, and when we come back, Kirk will have something hopefully less painful.
Oh, good.
Maybe not.
Okay.
Oh, good.
Brace yourselves, everybody.
It is one of those episodes, huh?
Hey everyone, welcome back to the show. My topic is not, I don't think it's particularly cringy or anything. It might involve a little pain, as you noted. So this week's topic started out as a note I put down in my ideas file. And I have no memory of putting it there, but sometimes when I come across something cool, I just jot it down and wait for the right time to be apparent. And that's now. It's the right time for these two special words that I wrote down. Those words are Ophthalmalia nodosa. Now, you might be tempted to be thinking that this is like a genus species for some animal, but you'd be wrong.
Mm-hmm.
This is, I'm afraid, a medical condition.
It's something wrong with your eyes.
Yeah, if we crack out the old Latin, and try to break it down.
No.
I figured you would guess
some kind of lump in your eye.
Oh, no.
Rachel doesn't like people talking about eyes.
I'm a little squicked by eyes myself, I have to admit.
Kirk, my cat almost took out one of my eyes. No.
Rachel, you can just
I remember
tune
that
out for a little bit if you want. It's actually not. It's not going to be as horrifying as some of the things that can happen. So, so ophthalmalia is just like ophthalmologist. Like it has to do with the eyes. That sort of phrase there. The second bit though is tougher because nodosa is not a word we commonly use. It comes from the Latin word nodosis, which means knotty, and that's knotty as in like knots you tie in a rope, not naughty as in like. You're a
very naughty boy.
Or bad. Yes. Just into knot tying. So there's a number of medical conditions and diseases that have nodosis at the end of them, presumably because they make something look knotted. But I'm going to be honest with you and let you know that I really have no idea why they chose that particular word in this case, because ophthalmia nodosa doesn't mean, at least as far as I can tell, that you have knotted eyes. It's really just a form of irritation or inflammation of either the cornea, conjunctiva, or iris. That's all it is. It's an inflammation to those areas. And technically, I guess it can have a few different causes, but the one I want to talk today about is caterpillars.
Oh, God. Okay.
What?
Now, yeah, caterpillars.
Oh, boy.
Now, just to set everyone's mind at ease, no, my topic is not caterpillars living in people's eyes. Okay, let's just get that off. Get that off the table. That's not what I'm talking about.
Because that's what I was thinking, and I was fully like,
I know it was, and I had to get that out there. No, that's there. Look, dear listeners, there are things that can end up living in your eyes.
No.
Oh, we'll get to them.
We'll get to them on this show at some point. I get the feeling they're already on Victoria's list somewhere.
No.
So, she very confidently just said, we'll get to them. So I assume they're coming.
Oh, no.
Well, no, what I'm talking about here is having a part of a caterpillar in your eye, specifically their hairs.
Mm-hmm.
So
they're non-hair
This
hairs.
has come up, tangentially on the show before, but I thought it deserved its own topic since it's so fascinating. And I think most of us have seen a fuzzy caterpillar before. So those listeners in North America, being like all of Canada, US, and Mexico, are likely most familiar with the black and brown woolly bear caterpillar. That's the most common one we have in North America. They're covered in tiny hairs, and those hairs are what causes irritation. And that's basically part of why those hairs are there, is to cause irritation. Now, most people can pick up, especially woolly bear caterpillars, with like no issues whatsoever. I pick them up and show them to kids all the time.
Oh, yeah.
And kids I work with pick them up and whatnot. If you were to crush one in your hand, maybe, which gross, why are you doing that? But like that could maybe cause some problems. But generally, it's not a problem. Apparently, though, some people can have reactions from woolly bears that range from irritated skin to actually nausea, which is pretty wild. These little hairs can be incredibly irritating.
I mean, that's the whole point of them.
Some caterpillars can cause a much bigger reaction. We've talked about a few of them on the show, but let me introduce you to one more, the pine processionary caterpillar, which is, I'm going to try to pronounce here, Thaumatopia pidiocampa, and it's found in Southern Europe, Northern Africa, and the Middle East. So you can kind of picture a little heat zone map of kind of that area. And like many other caterpillars, they have these hairs that break off and can cause irritation. And these are known scientifically as irritating hairs. Other animals, like some spiders, have these too. And the action is often physical, like they stick in your skin and they cause a physical irritation just by the very nature of them being there. You can imagine very fine little like stiff hairs getting into your eyes.
Sure.
How irritating that would be. One eyelash is almost excruciating when it gets in your eye.
Yeah.
If you had dozens or hundreds of these little tiny things in your eye, you can see my nausea might very well be on the table for you.
Yeah.
But sometimes they do even more. And in the case of the pine processionary caterpillar, those hairs contain a toxin called thaumatropin. So thaumatropin can cause an actual allergic reaction. And that reaction can be so severe, it can actually cause a person to go into anaphylactic shock. And naturally, that can lead to death if not rapidly treated. The route of exposure can naturally be the skin, if you touch something, but also if they get airborne, the hairs can end up in the mucous membrane of the nose or even, in the eyes.
Oh dear.
Now, I do want to point out that anaphylaxis is rare. So not everyone who comes into contact with these or many of the other caterpillars with irritating hairs will experience such a dramatic reaction. But the point is that these small creatures are very vulnerable. they're just squishy little worm-like things, very tasty to birds and other animals, and they need some kind of defense mechanism. And I talked about the relationship between moths and plants last week. Plants are older than moths, but moths have been around for a long time. They are older than their cousins, the butterflies. We found moth fossils from 190 million years ago. And actually, their close ancestors go back as far as 300 million years. So that's a long time to evolve defense mechanisms against being eaten. And it turns out that covering your body in hairs that irritate the skin, mouth, nose, and eyes of other animals trying to eat you is pretty effective. Now, do we as humans need to worry about this? Probably not. I mean, in general, you can be safe by not picking up caterpillars. When you see them, take a good look. They can be beautiful. They can be amazing. Get your camera out, document them, what's living in your area. Super cool. They're not going to shoot them across the room at you or anything like that. And specifically, if you live in Northern Europe there, I will say, if you were breathing a sigh of relief that the pine processionary caterpillar is only found in Southern Europe, well, bad news, I guess, for you. Due to global warming, the caterpillars are expanding their range northward. So if you start to see a new caterpillar that's kind of hairy and you've never seen it before, best is to take a photo rather than pick it up for a closer look and bring it up next to your eyes. Yeah, leave it alone because they have those defense mechanisms for a reason. Also, don't try to eat them because that's, then it's in your mouth. That's what I had. I just want to talk a little bit about, the pine processionary caterpillars and just about these irritating hairs in general, because I don't want to hear about any of you getting ophthalmia nodosa. Keep those hairs out of your eyes. It sounds horrifying.
Amen.
No.
Yep.
Mm-mm.
Well, I'll let you think about how horrifying that would be as we take a tiny little break. And when we come back, we'll see what Rachel's got for us.
Welcome back to the show, everyone. So we're heading out to Yemen today. We are going to a small archipelago called Socotra, and we are going for a very specific reason. I hope you all brought your hiking shoes because we're going up some mountains today.
Okay.
Oh, wow. Okay.
All right. So this is part of Yemen. And we are climbing up the mountains. And on the top of this mountain, on this plateau, are these actually endangered trees. And we get up there, and this is what we are here to see. We are here to see the dragon blood tree, or the Dracaena cinnabari.
Well, that sounds dramatic.
Oh, okay.
By the way, I'm so proud of myself. 2025, nailing the Latin names. Okay.
Nice work, Rachel.
I've had a Dracaena in my home before, Rachel.
I have as well, actually. It's in my office.
Yeah.
So
Dracaena?
Dracaena, yeah.
Yeah, we have one too.
Oh, amazing. So this particular tree is pretty amazing. It hangs out on the top of those mountains up on the plateau areas, and it looks very similar to an umbrella. It is an evergreen tree. The crown itself is very, very dense and packed down. There's a lot of spines, a lot of really thin, kind of what you would see in a Dracaena is a very thin, long leaf. The ones that tend to be used as houseplants are not this species, obviously.
Sure.
But they do kind of resemble the younger versions of this tree.
Okay.
Now, this is an evergreen, so it loses needles, loses leaves all the time. It's hanging out around the equator. It's in a desert. What is one thing that plants have to deal with when they're in a desert?
Lack of water.
Water loss.
Yeah. So we've talked a little bit about some ways that plants deal with water loss and how do they get enough water in order to grow. this is a pretty unique way for a tree or for a plant to like be able to deal with these types of conditions. Now, this is a monocot. So most plants that we think of are trees are dicot. They're two leaves.
Yeah.
A monocot are things like grasses and grasses. So it has secondary growth, which is pretty unique for a monocot. But, and it even has like something that looks like like rings around it, but it isn't. It just keeps growing. So the leaves are only found at the very end of the very youngest branches, and it ends up with this really dense looking crown. It truly looks like a big giant green like cartoon mushroom or like a cartoon umbrella, okay? Like really curved. Now,
okay.
Here's the thing. We'll get to why it's the way it is and how it is able to deal with the habitat that it's at. I do want to talk a little bit why it's called what it is called. Okay?
Yeah.
Great.
So it is called a dragon's blood tree. It's also called an umbrella tree, which looks like an umbrella, sure. But the very dramatic name, dragon's blood, comes from the berries that grow on this tree. Now, they are small, they're pretty fleshy, and they only have a couple seeds. And they turn orange when they are ripe. Generally, they're eaten by birds and dispersed and such that way. But those berries, even though they're orange, have a very deep red resin. So when the berries burst, looks a lot like blood.
Oh, wow.
Which is is wild. So that's the reason why they are called the way that they are. Now, because they are in such arid spaces, the large packed crown is one way that it helps prevent evaporation, which is that water loss. But another way that they have been able to, one of the things that they were able to do to help conserve water is because they live in a very arid space, there's not a lot of water in the ground itself, but they are surrounded by the ocean in the Arabian Sea, because it's an island, right?
Oh, yeah.
So what happens is they are able to take water from the leaves. They are able to absorb some water from the air and direct it down the branches to the roots. Because of the wide canopy, it helps prevent evaporation and prevent it from actually getting into onto just dry ground. It allows it to seep into the soil before evaporating back into the air. So this tree is able to take water from the air and direct it to its roots, so that way it gets enough water for it to be able to survive.
Sure.
Which I think is really fascinating and a wild way for a tree to be able to survive. Especially since these trees can live, these are a type of palm of sorts. They can live easily like 1,000 years.
Wow.
So.
Whoa.
So being able to get a lot of water and be able to survive year after year after year is pretty important.
Yeah, wow.
Yeah. A couple other pieces for the dragon's blood tree. It has a lot of uses when it comes to people. Right now it's being highly protected as it's only found on these 4 little islands on Socotra in Yemen. So they're pretty rare, so they don't get used anymore, but they were being used quite often for their resin, because their resin is also this deep red blood-like looking thing. So it's not just the berries, it's also the resin inside of the tree. They would use it quite often as a dye or in medicine and gluing pottery. The root could be used as medicine and in toothpaste, and was used to treat rheumatism. So there's been quite a variety of using the tree in medicine, but that has died down quite a bit because we want to save it as much as possible. The people of the island have been leading that effort. Yeah.
Cool.
It's wild. This is truly just a bizarre looking tree. It reminded me a lot of the baobab trees of Madagascar. Or Victoria, you talked about another tree, oh man, way, way back. And it reminded me a little bit of that one too. I can't remember exactly.
Not sure which one you're talking about.
Exactly. Yeah, I think it was quite a long time ago. Anyway, I just wanted to talk about the dragon blood tree today. I just thought it was really fascinating that it, for the most part, the outer layer of the tree really has those leaves, and it brings in water from the air and then directs it to its roots, rather than the roots bringing water up to the leaves themselves. So,
what did you say? What did you say the scientific name was?
Dracaena cinnabari.
Okay, there you go. So the cinnabar is a reference to the
color.
Red.
Yeah.
Mm-hmm.
Color, yeah.
Cinnabar is like a mercury ore, I think, that's red in color.
It's like a mineral that's really red. It's but it's toxic. So
yeah, I think it's a mercury ore.
Yeah, mercury.
Love it. Yeah. Love it. All right. Well,
so it must have a really pretty color. Yeah.
It's very deeply red. It's a really pretty tree. Well, my sources this week were Wikipedia. The Guardian had a great article, as well as National Geographic. And then there was a PubMed, the National Library of Medicine actually had a really interesting article called Dragon's Blood Secretion and Its Ecological Significance by Joanna Juremoric and Mirella Tulik. That paper was really cool in giving some more background of this tree, which was really fun.
Nice.
Cool. Thank you.
Thanks.
Yeah. I believe that's the end of the episode, right? That's everybody.
That's it. Wow. Until next time.
Until next time. All right. Until then, thanks everyone. Bye.
Bye-bye.
Bye-bye. Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.